So, my name is Ryan Hostetter, and my company is Integrated Wind Technologies. Just a little about myself first. Colorado born and raised. I'm a third-year Grandview Tech student, so I've been taking Grandview Tech classes since sophomore year. Last year, I earned my CSWA, so that's Certified SolidWorks Associate, meaning that I know basic skills with SolidWorks and how to use the functions and the application. I also have experience and training in technical skill. I know how to fix and repair mobile devices, phones, iPads, all that stuff. I've been working doing that, and I probably have about a year and a half of on-the-job experience doing that, so I really love all this technology and engineering type work, and I hope to go to fields where I can, work with physical devices and make stuff. That's why this motivated me for this project. I'm very passionate about physics. I've been doing AP physics classes for 3 years now. I'm the first student actually at Grandview to complete all 3 levels of AP physics. So I clearly like physics, even though there's a lot of people in here I know that do not. But I also am a future mechanical engineer student at the University of Florida, that's where I'm going next year. So I'm excited about that. And going back to my company, I am Integrated Wind Technologies, where with my logo here, I've got the big, black, bold, sharp logo here that I'm actually really proud of, because I really like this W I have in here that kind of symbolizes a wind turbine circular type idea with the blades, with the rough edges, and the blue for innovation, forward thinking. Throughout this year, this whole project, I have been working with my advisors. So my expert advisor is Mr. John Fregoso. He's a mechanical engineer at Portability Design Work up in Boulder. And my support advisors, Drake King, Kane Bruce, and Adam Powell. All of them throughout this year, they've all been in this class. They've been helping me out. I've been able to bounce ideas off them here and there, or annoy Kane about how to make something in Photoshop real quick because I don't know how to do it. But other than that, it's been great having these guys help me out. Starting this project for my wind turbine is that I had 5 goals that I wanted to accomplish. I wanted to learn how to use 3D printers and with the SolidWorks, so that I'd used a lot of SolidWorks before this, but I hadn't ever applied it with a 3D printer. So that was one of my big goals for this year. The next one was gaining knowledge and expertise in wind turbines and wind energy in itself, and I will go into some of my research that I did with that in a bit. The next part that I wanted to get to was gain knowledge about the patenting process and possibilities for the future as a business type idea with my model. I'll talk about that later as well. But the next part, of course, is actually designing a functional wind turbine to create electricity while being easily portable. The last part was earning my CSWP, so that's the next step in certifications for SolidWorks. And working towards that, I haven't quite gotten there yet. I'm going to work on testing next week. But here's my actual project. So going into what I wanted to do, my initial inspiration was that I wanted to have a wind turbine that I could set up, quick, move easily, and create electricity from using the wind anywhere I wanted. So with that, I had this idea that I could create a turbine inside a nylon tarp-like suspension that you could just tie to 2 trees or any supports where that would work. With the nylon suspension, I knew it would hold up the motor easily and steady where it needs to be, and I'd also be able to have breathability for the wind to pass through in certain areas. It's also durable. Using nylon is one of the best materials I could have used, best fabrics I could have used for this. It's durable, it stretches, and it's not going to tear at all. Even when I cut out parts of it, it wouldn't tear at those lines. So it was really a good choice for that. And the last part of why I wanted to use this nylon type tarp suspension is that this whole thing can roll up into the size of, well, I have it rolled up right there. The size of something small that you can fit in any backpack, sack, whatever you need to put it in to go wherever you want to go. So after that, or before I talk about that, this wasn't my project for this entire year. At the beginning of the year, I had a completely different idea with wind energy still that I need to mention that I had to switch from that around December to this new project. So beforehand, I had tried to integrate a wind turbine into the front end of a car to make it more efficient when it's going down hills, to maybe take back some of the energy that it's losing, or when it's braking, to take back energy from that. And basically what I found out from that is that it's just too much of a pain with the thermodynamics and energy equations for that this wouldn't really be feasible and it'd be less efficient. More of the inefficiencies of it had to do with electric clutching and braking and then closing the wind turbine itself. For it to actually work, I would have had to have this wind turbine be able to turn on and off at specific timings with regards to how the car is moving. And then I would have also had to enclose it so that it's not taking away any aerodynamics of the car. So that's why I went for my new project where it's actually possible. So with this new project, the description and overview of it this entire year has basically been that I want to research the aerodynamics, forces, and energy output, obtain wind, portable turbines that I can move easily, what I can create, and what's possible for me to do. And then research the wind energy and wind turbines itself, and design and create my model of a turbine that works. Starting with my research, one of the first things that I found when looking at wind energy is the Betz law equation. Betz law equation, it basically tells us the maximum power output we can get from wind energy spinning a turbine at the best possible conditions, which we actually have not been able to ever create anyway. So what we found is that this equation right here, this essentially says that of the power and energy flowing from the movement of the wind, we can only get about 59% of that in total if we had the best possible scenarios. And what we also found after that is that the best commercial wind turbines on the market can only get 80% of that 59% anyway at the most ideal conditions. After that, I needed to research the portable wind turbine market itself to make sure that I was different and that there wasn't someone already doing what I was doing. And what I found is that on the market today, all portable wind turbines that are sold are mounted onto tripods, and they're all tripod systems. And that has a couple of pros and cons that I'll get into when I talk about the end result of what I have, but comparing it to that. But what I also needed to do was find what type of motor does this, what generator can I spin to create electricity. And I basically found that it was just a very basic motor that with electromagnets fixed that's also geared for higher speeds, because this wind turbine needs to be able to spin as fast as it can, because you can't really control how much the wind is going to turn. The other ideas that I originally looked through for creating my turbine blades was first that I wanted to create them in SolidWorks like this with planes and lofts. And then a backup plan that I could also do is that I found online with some DIYs and different ideas that I can create wind turbines with PVC pipes when you cut them at certain angles and mount them in certain ways that they can also run a pretty efficient turbine. When I applied my Betz's law, I plugged in just some numbers for wind speed just to see the maximum power output in watts that I could find. For like watts is going to be joule per second. So we got at 40 mile per hour winds, which is very, very fast, we'd get a very large number for the watts output. And then I also applied a 70% of this power to kind of simulate a more realistic number with this Betz's law, because we're never going to be able to reach this, at least with today's technology. So with today's technology on the lower end, these are the best possible outcomes that we can get. These numbers also correspond with the area that my specific wind turbine passes through. So taking into account the size of my blades and everything, that's what I got these numbers from. So after that, testing my actual wind turbine, which I'm going to be able to do a demo here in a little bit, the maximum EMF I was able to get previously was 5 volts, and actually today I was able to get up to 7 volts. And previously I was also able to get 50 milliamps, and then now it's not reading, but after that, before I show you guys my actual model here, I wanted to talk about the three things that I really tried to tackle with this model. Is that it's easy to use, portable, and it's different. And I mostly glossed over that anyway, but the portability is my biggest part of this project, because with this motor, with this model that I have here, I can, I can roll it up into the size of that I can fit in the hand easily into any backpack, but at the same time, it can blow up to the size of this giant fan here that I have here to produce the most possible wind energy that I can. I'll do it demo. So, in a second here, I'm going to unroll my turbine and actually set it up for you guys to show you how simple and easy this is to use. So, as I unroll this, as I have it folded in a specific way, if I don't drop everything, they'll easily find. Hard to see. So what I have here set up today is I just built this PVC stand to kind of simulate some trees or whatever, support someone can set it up between. As I slide in these turbine blades into the hub, this motor itself levels out. Sits evenly. Here, I'll show this level. So, this is going to be a steady situation for this, safe as well. Set up right here is my multimeter that I'm going to be able to read off the current voltage that is EMF, electromotive force. So with this turbine here, and that took me maybe like 2 minutes to set up. So within 2 minutes, I can unroll this model and I can set it up and immediately start putting out potential. So this is creating electricity. And as it's going, obviously the faster that this spins, the more that these blades stick in here, as their design cuts in and out, so that as they are spinning, the normal force, which creates friction on these blades, increases. So as they're spinning, they're locking themselves in essentially. So, we're done with that. I'm going to move this aside so I get back to the other part of my presentation. So with my design process to create this model here, I had to start out with just getting my materials. And the first one that I got actually was my motor, a little DC motor that I have inside of the, it's called the nacelle, I'll come back to that later, but inside of the tube that's holding that all together is my DC motor that has an axle sticking out that the hub sits on from the blades. The next part that I got was the nylon for this to make sure that I got a sturdy enough material that I can suspend this motor with, that will hold it up easily and I can use properly for my project. Next step was First of all, when I first got my motor, I wanted to make sure it functioned. It actually put out electricity. So I just grabbed a simple ammeter right here. This measures current, so how much the motor is putting out electricity per second. And as I was spinning the front axle of the motor, it was pulsing on the ammeter. It was making movement, which is good enough for me that it works and functions. Next part of the modification I need to make to the motor was that on the end of this motor is only two little tiny connections that I've got here. So I had Adam solder two wires on here for me that would extend that so that I can actually use this other than holding something up super close to the motor while it's spinning. And next up was my SolidWorks design for the rest of my products, or the rest of my parts. The first part that I had to attack was the hub itself. The hub holds in the blades from falling off or just onto the axle itself. With this design originally, this is my first design right here, I just had this ducktail type design where it cuts in so that these will slide in the front and can lock in from falling outwards as they tend to pull from centrifugal force as it's spinning. I modified that design just a little bit, adding fillets at the edges of this hub where the blades would connect in, just to distribute the force from just being on an edge that would maybe break or snap off to being on a round edge with more surface area that can distribute that pressure. Here's what this turned out to look like after I printed it. And so I designed it and I 3D printed this in our printer here. This is just with comparing it with what the motor looked like and just a couple of different views. Next was the probably more difficult part of my project, was figuring out how to design a turbine blade itself and what I needed to do with this. So after looking up some ideas from SolidWorks.com forums and stuff like that, I found this diagram right here outlining that I need to create planes with drawings on each of them that would be cross sections of my blade as I go, and that I need to create two guidelines to lock this through. Doing that, here is my lock here. I have to change it a little bit from this. I no longer have a point on the top for a couple different reasons. One, there's no need for it to be a point on the top. And two, if I have this spinning at full speed, and I have this blade come to more of a point at the top, and some gust comes by and rubs it against the nylon, I did not want that to just tear through my nylon. So that's why I made that design, so it's got more of a flat top. After that, what I needed to do was figure out not only the design that I created in SolidWorks, how to do that, but what process to 3D print this with. So do I need to print this from a horizontal up? Do I need to print this completely vertical? As my first design here was printed horizontally, so I was sitting like this, and we printed it upwards, and it kind of created a very rough edge as the different steps of the 3D printing process really showed up on this, and we didn't enjoy that one as much. So the next process that we tried was printing the next blade vertically. And as it did create a smoother surface, it still was very choppy at the edge there as pictured. And the final product that is on there, as well as right here, was printing it in this type of horizontal, I don't even know how to call this oriented, with the blade pointing up. This created a very smooth surface, and it also eliminated one of my other problems that these had, where as my print lines are vertical in this situation, any collision that this would have would cause break lines horizontally to this. So printing it in this way actually made it more stable and more durable from any collisions or problems that could arise. As the last process was actually putting it all together. So I got the blades printed, I got the hub printed, and then I've also worked with my fabric a little bit. And what I originally tried to do was create a tube that I could put my motor into and then screw into the fabric however I wanted to do that. And I thought I'd be able to just find like PVC pipe or something like that that I could easily deal with for this size, but nothing fit my motor correctly. So I ended up having to print that part as well. Actually helped me out because then I can make different screw holes right exactly where I needed them to go. And this part is actually called the nacelle. It's what holds all parts inside of a wind turbine, the motor, and traditionally it would be braking and clutching systems as well for a actual wind turbine that is used on a larger scale. For this, it's not necessary. After that, the next part that I actually had to do as well is that this is very front heavy from this situation. I had to put some washer weights on the back of it to balance this out and level this. So that comes with this. This picture always makes me laugh because I don't know if you guys can tell very well, but on the back of this is when I was just trying to see the exact weight and just double check my calculations for how much weight I needed on. I just put any screws I could find around in the house, taped them on there to see what it really needed. Trial and error, right?
I guess.
So after that, weighed it and then figured out the exact, washers that I would need for this, screwed them onto the back, and it fits perfectly. It sits level, and it was a really good process. So, as you'd seen before, this is it rolled up. It's much, much smaller than this entire contraption here, I would think. And that's what I aimed to do, was make it work. So I think I accomplished that. So going through my project objectives here, I want to touch on these. I did learn how to use 3D printers with the different parts that I didn't need to print out for this model. So that one is green because that worked. Gaining knowledge on using wind turbines, I can say that I definitely am more knowledgeable into this topic and this area of science. The next part was about a business idea with patenting this model, this idea, that I didn't really have a chance to get to as my project kind of shifted in a different direction of 3D printing with these blades, where originally I thought I'd be able to find blades and everything, and this turned more of an engineering, modeling type project that I needed to do. The next part then was to design a functional wind turbine, which, as I just demonstrated, this does create potential, this works, and it is portable. So I think I can say that's a success, at least a little bit. Next was earning my CSWP. As I have practiced on this model itself, moving forward in the next actually week, I wanted to try to test for my CSWP. So that's why it's a blue color, because it's hopefully going to get done, but it has not been done yet. Moving through my timeline, some of this time translates over to my first project of what I wanted to do as these with the different types of research that I had aimed to do by certain times. So October, November, and then December is when I had to change everything up. So I met with my advisor, talked about a few things, and too many issues, as I talked about before, caused me to just have to find a completely new idea. So December, my timeline entitled, do my job shadow write-up after this discussion, and then brainstorming an entirely new project, essentially. Something in the same realm that I could use wind turbines and all my research, and most of my research that I'd already done, and what I'm already passionate about for the reason that I wanted to go work with wind turbines to move forward. So I created a list, did some different ideas, and then I shot my final idea to my advisor, and we definitely found that this would be possible, and this is the right thing to go. So January also is something where I had to switch everything up. So what on this right side here is what my new timeline entails. I had to make this entire new timeline for this new project as I chose my idea, made the timeline, had to do my mid-year presentations, as the advisor talked about. This just kind of goes back to my work where I talked to him to verify that this idea works. So ordering parts, I was pretty vague on what I wanted to do here because I didn't know which, starting a new project, I didn't know what parts I would need first. So I got some of them ordered here, some of them on the next part. So here, the rest of my timeline is going to include these teal colored text because it's things that got done, but maybe didn't get done right at the exact time that I previously wanted them to do. So in February, I did start 3D printing. Didn't get all of it done because as I realized I would be 3D printing basically until one of the last months here that I had to work on this project. The next part was construction of my building, the way and everything. This was all done later. I was able to get it done, just not exactly at the specific time that I had detailed. Finishing construction of the mop fabric and turbine. This was actually first of April. Connected method of measurement. I did get this done in March where I found the multimeter and I did test my motor with some contraption on the front of it to make sure it was turning. That was putting out electricity. Beginning of April, before this all, I did finish up with my testing. I finished up with a couple with printing my nacelle and putting it all together to create this project. The last week or two I spent working on building this PVC contraption here, practicing with it to make sure that this does hold up and this is portable. And on the bottom, the last thing that I was able to do in April was thank all my advisors for all their work. So I just want to say, take a moment here and thank each of my support advisors and my expert advisor for all their time. So now that's green, so that's it. And I got my bibliography here, so if any, did all my research. And if you have any questions, no way.
So what's the benefits between the system right there and the tripod system?
So with the tripod system, you can set it up, orient it in any direction possible, but we also lose the stability that this has, as it's only rooted at the bottom, where this is rooted from top and bottom. It can't be blown over. Like I said, the tripod, it can be kind of oriented and say, hey, the wind's coming from this direction, I can orient it to this exact direction. This, you have to have some kind of structures that are at least close to the direction. So, Adam.
So sort of along with that, will you find any like huge efficiency discrepancies if it's not pointing in the exact direction with the
Yes, there will be a significant discrepancy, but when I was modeling this out, I was looking more towards, hey, can I do this? Can I make this portable? And if there is a situation where, hey, the wind is coming from this way and I'm in a forest, I can most likely find a situation where trees will allow me to do what I want to do. So that was my goal with that. There is a very big drop off with the directions, but it comes.
Did you try, I know you've been doing some drill, did you actually try putting a fan or some kind of?
I did put it out in wind, and it does turn, but I wasn't able to get any numbers specifically off that situation. So it does turn from the wind. It does function that way, and because it was turning, it definitely was putting out electricity. No, again?
Yeah, sorry. Saying hypothetically, perfect conditions for this machine are possible, how long would it take to like charge a cell phone battery or?
Well, depends on a couple of different things. So, winds isn't necessarily always constant with how it changes and everything, so you can't predict exactly how long it would take for that. But like I said before, I can put out about 50 milliamps, and just to give perspective, a average cell phone battery is around 1500 milliamp hours, so it would be quite a while. It's slow trickle charge, but it would do something. And that's the idea, is that this isn't going to maybe be the most efficient operation, but it will do what it needs to do to get the job done.
How does the price of yours compare with the price of the tripod?
So the price of the tripod turbines were almost always exceeding $100, around $200 each for the small models. With this, I was able to create this entire project for less than $100. So there's how that compares.
You can do version 2.
So with version 2, I'd like to make an ability to possibly change a little bit of direction, maybe 15 degrees in each, to account for the idea that maybe we don't have a perfect situation with the wind coming at the right direction. so that that can at least help in that situation. And the next would also just be have quicker solutions for maybe professionally done blades that aren't designed by me, they're actually made by a company that does actual turbines, so that I can create and have even easier rotation, more efficient with anything else?
Well done, nice questions.